Hello, welcome to part one of the homework. What we have here is we have a function h, big H, defined by an integral. And we're asked to find a few things. Some involve derivatives and some just involve the function h itself. So for h prime, that is the derivative of h. So if we're given this function h that's defined by an integral, if we want to find the derivative, then that means we're going to be finding the d dx. We're going to find the derivative with respect to x of the definite integral. And here we have that perfect setup for the fundamental theorem of calculus part one. So what we have is we have a derivative with respect to x of a definite integral with a number on the bottom and a variable up top. So the fundamental theorem of calculus part one allows us to skip the whole process of finding the antiderivative and plugging in and then finding the derivative. We can just take the shortcut that says you grab the integrand and swap the variable. So you're just going to get cosine of x for that one. Now for number two, the directions are different than what we're used to. So this says write an expression for h of x, this is h of x, without the use of integrals. So what that's code for is go ahead and actually evaluate this. So what we're going to do here is we're going to do FTC part two to rewrite this without having the integral symbol. So if we have the definite integral from pi over 2 to x of cosine t dt, then what we want to do is find the antiderivative. The antiderivative of cosine is sine, and we want to evaluate that from pi over 2 to x. So we're going to plug in the upper limit of integration first, and then the lower limit of integration. And the sine of pi over 2 is 1. So here's our final answer, and the sine of pi over 2 is 1 because if we sketch pi over 2, the y-coordinate is sine. Now for h prime of 5 pi over 6, since we found h prime before was cosine x, let me write that down. So going back to number one, we found out that h prime of x is cosine x. So if we want to find h prime of 5 pi over 6, we can just plug right in for x. And the cosine of 5 pi over 6 is negative radical 3 over 2. If you're a unit circle person, you'll think of your unit circle, and the x-coordinate is the value of cosine. If you are a triangle person, your reference angle for 5 pi over 6 is 30 degrees. So you go to your 30, 60, 90. And for 30 degrees, radical 3 over 2 is the value of the ratio for cosine. And then since you're in quadrant 2, only sine and its reciprocal are positive there. So that's why it's negative on that. And then the last one here is number 4. We want to find h of 5 pi over 6. So since h of x is defined as the definite integral from pi over 2 to x of cosine t dt, if we want to find h of 5 pi over 6, then what we can do is plug in 5 pi over 6 in place of x anywhere we see it. So we're going to plug that in for the upper limit of integration. And the antiderivative of cosine is sine. That variable is still t, by the way, because we are integrating with respect to t. So we're going to go ahead and plug in the top number, which is the upper limit of integration, and then subtract the antiderivative evaluated at the lower limit of integration. The sine of 5 pi over 6 is is 1 half. Sine of pi is 1. So we end up with negative 1 half for our final answer. And that's one way to do this. Just to note, since we did earlier in the problem actually find that h of x, this right here. So since this is h of x, when we evaluated that, this is still h of x. Okay, so this integral is equivalent to this expression right here. So when we go to find in number 4, h of 5 pi over 6, we actually could jump right in and put 5 pi over 6 right there. And so if we were to do that, we would still end up with a negative 1 half.